Hi, Assalamualaikum. My name is Muhammad Amirul Amni bin Zaidi, metric number AF190141. So now I'm going to start with our introduction for Group 8. The ability of slope soil or rock slopes to endure or undergo movement is referred to as slope stability. In soil mechanics, geotechnical engineering and engineering geology, slope stability is a topic of study and research. When these variables are integrated over a possible or real sliding surface, the ratio between available shear strength and active shear stress, which can be described in terms of a safety factor, determines the slope stability. The safety factor, computed along any potential sliding surface running from the top of the slope to its toe, must always be greater than 1 for a slope to be considered globally stable. The slope's global stability criterion will be represented by the safety factor's minimum value. Hydrologic events, earthquakes, internal erosion or surface or toe erosion, artificial slope loading, slope cutting or slope flooding are all factors that can cause slope failure. When there are infinite slopes, translation failure occurs, and the failure surface is parallel to the slope surface. The most common type of failure is toe failure, which occurs when the failure plane crosses through the slope's toe. When there is a weak soil strata under the toe and the failure plane crosses through the base of the slope, base failure occurs. It is similar to translational failure, except translational failure only happens on infinite slopes, whereas wedge failure can happen on both infinite and finite slopes.
Assalamualaikum. My name is Muhammad Yazim Bapu. I will present for the slide literature review. In the study of slope, a slope construction basic theory is very important in regards to type of soil movement and stabilizing methods. Slope construction is closely related to soil, and it is crucial that we understand the background of soil and slope analysis methods that have been practiced in the construction of new slope or remedial of existing slope. A general definition of the factor of safety F of the slope results from comparing the downslope shear stress with the shear strength of the soil along an assumed or non-rupture surface. A great variety of slope movement reflect the diversity of conditions that cause the slope to become unstable and the process that trigger the movement. Water and wind continuously erode natural and man-made slope. Erosion changes the geometry of the slope, ultimately resulting in slope failure, or more aptly, and landslide. Rivers and streams continuously scour their banks, undermining their natural or man-made slopes. A thin scene of seed under a thick deposit clay can easily be overlooked in drilling operation, or one may be careless in accessing borehole logs only to find later than the presence of the seed caused a catastrophic failure. Sloping stratified soil are prone to translational slide along weak layers. Loads placed on the crest of a slope add to the gravitational load and may cause slope failure. A load placed at the toe, called a berm, will increase the stability of the slope. The net effect is that the slope can fail under undrained conditions. Seepage of groundwater will occur, and additionally seepage force can provoke failure. By changing the geometry of the steep slope to a gentler slope, either flatten the slope or backfill at the toe of slope, the stability of a slope can be increased. Retaining structure have different varieties. The remedial work proposed by POST carry 4 groups, namely slope geometry, drainage, retaining structure, and internal slope reinforcement. The alternative in the category of slope geometry involve fundamental changes that include removing material from the landslide driving area and reducing the slope angle. The category of the retaining structure include provision of different types of structure to give stability to the slope, while the category of internal slope reinforcement include providing anchors, micropiles, and soil nailing. Thank you.
Hi, Assalamualaikum. I am Muhammad Iqbal Rizal bin Muhammad Rizwan. I am presenting the technique of slope stability. So for technique chosen to remediate the slope failure, which is a retaining wall construction, is one that is designed and built to withstand lateral soil pressure or to hold back soil material. It is moderately solid walls that are used to hold soil laterally in order for it to be retained at various levels. Restraining walls are also intended to prohibit dirt from spontaneously adhering to a steep, near vertical or vertical slope. For the reason on technique chosen is retaining walls can also provide pedestrian access to steep areas. Instead of walking up and down the slope region, they can walk comfortably because it is flat due to the retaining walls. Following that, the retaining wall structure technique might aid in drainage improvement. It can be used to control the flow of water in certain places. This is especially useful when the slope is near a body of water. So next is type of retaining wall structure technique. First we have gravity wall, which is a gravity retaining wall is a form of regular wall that support the ground mostly by its own weight. Because the internal leverage of the pressure is so significant, it can pivot and topple very quickly. Second we have piling wall. Piling wall is an earth retention and excavation support technique that use a victimization sheet segment with interlocking edges to keep dirt. The piling retaining wall is held in place by soil on both sides of its lower length due to the use of lengthy piles. If the piles can withstand bending force, the retaining wall can withstand heavy loads. Third, we have cantilever wall. So for cantilever wall, are constructed with an internal stem of steel reinforced case in place concrete or mortar, ensuring that it is frequently shaped like an invert T. The cantilever wall stabilizes itself with a second lever arm by using the same earth pressure that is attempting to topple it. Lastly is anchored retaining wall. When space is limited or a thin retaining wall is necessary, an anchored retaining wall is used and built. This type of anchored retaining wall is appropriate for loose soil over rock. This sort of retaining wall prevents topping by using cable driven into the soil or rock and held the place by expanding anchors that can be integrated with other types of wall. Therefore, retaining wall design guidance and consideration. Retaining walls are vertical or near vertical structures that are designed to hold material on one side, keeping it from collapsing, slipping, or eroding. Retaining walls sustain terrain where the angle of repose of the soil is surpassed and it would otherwise fall into a more natural form. The main feature of a retaining wall is its ability to withstand the pressure produced by the retained material, which is often earth. As a result, the specific requirement, criteria, and consideration will differ based on the project. Walls can range from simple landscape stone wall that surround a garden to massive soil retaining construction that run beside a highway, while others might assist, manage erosion, or create a tiled yard to reduce maintenance. Several elements and consideration will influence the material and type of wall that is designed and built.
Assalamualaikum, this is Rifat Mahmud with the metric number DF19252. I would like to explain about the application of any standard. So first of all, we need to know the geological map of Malaysia and the location study. The failure region lies within the area of granitic bedrock formation of the Mesozoic or younger age. So here with this figure are 24-25 holes were drilled inside the failure zone and in the surrounding area. So this figure is about the cross sections of soil stratum along the slope profile at main failure area. So that we need to follow the factory of safety. Here is the pile retaining wall. We can use as a remedial works and correct the existing condition on the right hand side slope at the construction of the pile retaining wall to interrupt the failure point in order to limit possible global instability and guarantee appropriate shocking into the hardest frame. So first of all, this approach is quite expensive, but it is very adaptable. Retaining structure are employed in this manner which tends to pressing pressures to soil masses. There are several types of retaining wall structure, and sometimes soil nailing is used to support slopes, and gravity retaining walls, pile retaining walls, contiguous piles, and etc. So here is the landslide remedial work. So first of all, the slope geometry, and then drainage and retaining structure, and internal slope reinforcement with rock walls, micropiles, and soil nailing. So here is for example this slope angle and depth and length, the maximum slide plan is vertical D, and length slide is L, and the inclination or line between head and slope horizontal is beta. So here are some examples of drainage features like unlined drain, partially land drain, line drain, and rectangular line drain, etc. So what is the cause actually? The primary cause of the slope failure is attributed to a rise in the groundwater level caused by long-term rainfall, continuous creep of the slope over a long period of time, and sustained saturation of the slope at pockets of voids within the slope mesh, as the slope was built using hand tipping. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abid bin Muhammad Sharif. My nomenclature is CF190240. Today I would like to explain my part for our group project, which is our group is number 8. So I will explain about the long-term stability for the chosen technique. First of all, we decide to use a retaining wall as a method of resolving slope failure. Second, a retaining wall is a large structure intended to hold land in place and prevent soil erosion. Landslide inertia are caused by the most basic of human errors, incompetence, a lack of maintenance system, ignorance of delicate inputs, unethical behavior, and other negative human activities. So, landslide inertia happen on man-made slope, which can be linked to the substantial development in hillside area. Recent advancements in risk analysis and risk assessment are following for the development of more systematic and rigorous slope management processes. And finally, risk analysis and assessment has become a popular approach for dealing with the uncertainty that comes with landslide hazard in recent years. That's all from me, and thank you.
So in conclusion, gravity retaining walls, pile retaining walls, contagious board piles, caisson, steel sheet piles, ground anchors, soil nails, and other retaining structures are examples of retaining structures. Gravity retaining wall is to resist lateral ground pressure and it's rely on their mass. Cantilever retaining wall are constructed with an internal stem of steel reinforced, cast in place concrete or mortar masonry that is frequently shaped like an inverted T. Cantilever retaining walls are made up of a stem and a base lap. Anchored retaining wall is used and built when space is limited or a thin retaining wall is necessary. A high retaining wall can be built by utilizing the anchored retaining wall structure technique.